Good evening, children. In today's videos, I'm going to teach you as a continuation of light energy, and today we will see into the spherical mirrors. Spherical mirrors. Spherical mirrors are made by silvering the part of the hollow sphere. The surface on which silvering is done is called the silvered surface, and reflection takes place from the other surface, which is called the reflecting surface. So if you look in this diagram, the silvered surface is marked with those small vertical lines, and the silvered surface is the one that from where we block the light rays from going through the mirror, and the reflecting surface will be on the other side. Now, there are two kinds of spherical mirrors. One kind is a concave mirror, and a concave mirror is made by silvering on the outer surface of a hollow sphere such that reflection takes place from the inside hollow surface. So we silver the outside, then the reflection will take place on the inner hollow surface. So it forms a concave mirror. Then the other kind is a convex mirror. A convex mirror is made by silvering on the inner surface such that the reflection takes place from the outer convexed or bulged surface. So if we silver the inner surface, then reflection will be on the outer or the bulging surface. Then it forms a convex mirror. Terms related to a spherical mirror. Number 1, the pole. The geometric center of the spherical surface of the mirror is called the pole of the mirror. It is the midpoint of the aperture of the mirror, and it is represented by the symbol P. Okay, so the pole of the mirror is this. And in both the cases, here we have a concave, here we have a convex. So it is the geometric center of the mirror. This is the part of the sphere which forms the spherical mirror. So it is the geometric center, which means it is the midpoint of the surface of the mirror. And the symbol for pole is P. Then the next is center of curvature. The center of curvature of a mirror is the center of the sphere of which the mirror is a part. It is represented by the symbol C. Okay, center of a sphere. So here is a sphere, here is its center. Here is a sphere, and here is the center. So the center of the sphere, out of which we take the mirror. This center is known as the center of curvature, and center of curvature is always symbolized by capital C. The next is radius of curvature. The radius of curvature of a mirror is the radius of the sphere of which the mirror is a part. It is the distance of the center of curvature C from any point of the surface of the mirror. It is represented by the symbol capital R. Okay, the radius of a sphere. The distance from the center of curvature to any point on the circumference of the sphere. Okay, to any point. So if we take from here to here, this will be the radius of curvature. If we take from here to here, it will be the radius of curvature. And remember, all radii of a sphere will be equal. So we can take it at any point. Then we get the radius of curvature. The next term is the principal axis. It is a straight line joining the pole of the mirror to its center of curvature. So if we join the pole, okay, the pole to the center of curvature, we get what is known as the principal axis. So here is the principal axis, the one in dotted line, okay. So we have the principal axis here, okay. So this is the principal axis, and principal axis can be extended on the other side, since in the case of a convex mirror, reflection will take place from the bulging surface, okay. Remember, principal axis is a straight line, so it will be always represented by a straight line. Then we have focus of a concave mirror, okay. The focus of a concave mirror is a point on the principal axis at which the light rays incident parallel to the principal axis meet or converge after reflection from the mirror. So, the principal focus of a concave mirror, this is a concave mirror, so it's a point on the principal axis, such that all rays which are incident parallel to the principal axis after reflection will all meet at this point. Any ray that is parallel to the principal axis after reflection will pass through this point. So if there are many rays, all of them will converge or meet at this point. And this point is known as the focus of a concave mirror. In the case of a concave mirror, the principal focus or the focus is a real focus. Why? Because all real rays will converge at it. So when real rays are converging to a point, it will form a real focus. Then focus of a convex mirror. The focus of a convex mirror is a point on the principal axis at which the light rays incident parallel to the principal axis appear to meet after reflection from the mirror, okay. And look here, because we have the reflecting surface from here, so we have incident rays parallel to the principal axis, okay. Now in the case of a convex mirror, these rays will be reflected in these direction. They will be reflected in these direction. So not the real rays are going on the other side. So what do we do? If we look at these rays, they form diverging rays, and diverging rays will go away and away and away from each other as we make them to be longer, okay. So what do? We draw them backwards by dotted line. And if you draw them backwards by dotted line, we see that they appear to meet at this point on the principal axis. So we have appear to meet. It's not actual converging, all right, like in the case of a concave mirror. They appear to meet. They simply appear to meet. Not the real rays are converging, all right. So this point where the rays appear to meet, when we produce them backwards, this point is known as the focus of a convex mirror. Since the focus of a convex mirror is formed by the rays which are produced backwards, not by the real reflected rays, so the focus of a convex mirror is not at all formed by real rays. As a result, it will be a virtual focus. It's not a real focus, okay. The next term is focal length. The distance of the focus from the pole of the mirror is called the focal length of the mirror, okay. By the way, I forgot, for the focus, symbol is capital F in both the types of mirrors, but focal length is symbolized by small f. So what is focal length? Distance from the pole to the focus. From the pole to the focus, Okay, so this is focal length. This is focal length. Okay, focal length is real, because be it in a convex mirror or in a concave mirror, the distance is real. Okay, so we have real focal length. The relation between focal length and radius of curvature, please remember these relationships. Focal length is equal to half of the radius of curvature. Okay, focal length is half of the radius of curvature, and radius of curvature is equal to twice the focal length. This is important because when you draw the ray diagram, you take the measurement, and it will be very important when you take the measurement that you take focal length and radius of curvature to be the same measurements, but remember, radius of curvature will be twice as much as you take the focal length. For example, if you take focal length to be 2 centimeter, then radius of curvature, it will be 4 centimeter. All right, because it will be twice the focal length. Then for the laws of reflection, in your textbook, they have mentioned them, all right? But you learned them already in class 7. So just a reminder, I just stated, and please learn them from the textbook. The first law, the angle of incidence is always equal to the angle of reflection. Angle of incidence is symbolized by small I. Angle of reflection is symbolized by small r. So small I is equal to small r. Okay. Then second law, the incident ray, the reflected ray, and the normal at the point of incidence, they all lie in the same plane. So these are the two laws which you already learned in class 7. So please memorize the laws and learn them from the textbook. Then we go to the rules for making the ray diagram in a spherical mirror. Very important, because the rules you need to know before we go into the ray diagrams shortly. There are 3 important rules to be kept in mind. Please memorize them. Number 1, the object is kept in front of the reflecting surface on its left side. Okay? Object where? In front of the reflecting surface and on the left side of the reflecting surface. So when you draw the mirror, reflecting surface should always turn towards the left side. So object can be on the left side. 2, the object is always kept on the principal axis such that it is perpendicular to the principal axis and its foot touches the principal axis. It means you have the principal axis, okay, and then you keep the object perpendicular to it, and then the foot will touch the principal axis, but the tip will be up or down depending upon the need, okay? But the tip will never come on the principal axis. It's the foot that will touch the principal axis. I hope that is clear to you, okay? Then point number 3, for constructing a ray diagram, take at least 2 rays of convenience whose paths can be traced after reflection. That means to get a ray diagram, a minimum of 2 rays should be taken. Okay, now I'm going to explain to you about the convenient rays. Out of those which we are going to learn, we are going to learn 3. You are not to take all the 3, but at least 2 convenient rays should be taken in order to get the point of intersection for the formation of image. Okay? And usually when we choose a ray, it should be the ones that we know where the reflected rays are going. That's what it means when we say whose paths can be traced after reflection. That means we know where is the direction of the reflected rays when we choose the convenient rays. I hope that is clear to you. Please memorize the rules for making ray diagram in a spherical mirror. Now we go to the convenient rays for drawing the ray diagram. Okay? And here, may I remind you children, it's not just the writing parts that are important. The diagrams are equally important. Okay? So please practice. All right. The first ray that usually we choose when we draw the ray diagram, except when it is not possible. Whenever it is possible, choose this ray first. Okay? What is it? A ray passing through the center of curvature. Look at this ray. A ray passing through the center of curvature. Okay? This ray, a ray passing through the center of curvature is reflected along its own path, meaning it comes and then it is incident on the mirror, then it goes back along the same path. This is the reason why I'm saying if it is possible, choose this ray first, because you don't have to draw two rays in order to get the reflected ray. Only an arrow for going, arrow for coming back is needed in order to get the complete ray, incident and reflected. Okay? Now, the same is true here. And in this case, it is appearing to pass through the center of curvature. This ray is incident and then it is reflected back along the same path. Okay? Why is it so? Here, a ray passing through the center of curvature is incident on the spherical mirror, is incident normally on the spherical mirror. Remember, we talk about normal incidence. When it is incident normally, remember, when it is incident normally, angle of incidence will be 0 and then angle of reflection will also be 0. So what happens? The ray will be reflected. In other words, we say the ray retraces its path. Okay? So we have the ray gets reflected back along its own path. Get it, children? Look, it comes and goes on the same path. Only an arrow should be marked. And please remember, children, no line is called a ray unless and until you mark it with an arrow. Okay? For incident, we mark an arrow pointing towards the mirror. For reflected ray, we mark an arrow which is going away from the mirror. So that makes a difference between incident ray and reflected ray. Okay? So whenever it is possible, choose this ray first in order to draw the ray diagram. Then the second which you shall choose, all right, next to the first one, next choose this one. A ray parallel to the principal axis. A ray of light incident parallel to the principal axis after reflection passes through the focus in case of a concave mirror or appears to come from the focus in case of a convex mirror. A ray incident parallel to the principal axis. So here is the principal axis. Here we have a ray which is incident parallel to the principal axis. This ray will not take any other path. After reflection, it will always pass through focus. Or in the case of a convex mirror, it will appear to come from the focus. Look, real reflected ray is here, but it appears to come from the focus. Okay, so this is the ray that we should be choosing next to the first one. Then thirdly, a ray passing through the focus. A ray passing through the focus in case of a concave mirror or appearing to pass through the focus in case of a convex mirror gets reflected parallel to the principal axis. Look at this. Here is an incident ray. Now you can make out. Look at the arrow. It is pointing towards the mirror. So this is an incident ray. An incident ray passes through the focus. All right. Or here is an incident ray appearing to come from the focus. All right. So what happens to this? This ray, all right, after reflection, it will become parallel to the principal axis. It will become parallel to the principal axis. So if I produce this principal axis this side, this ray will be reflected parallel to the principal axis. In both the cases, the reflected ray will become parallel to the principal axis. Okay. Now we choose the third one only in cases where the first and the second, any of them is not possible to be taken. Otherwise, we will choose those two first. Then we go to real and virtual image. Real image. An image which is formed by the intersection of the real reflected rays is called a real image. Okay? An image which is formed by the intersection of the real reflected rays. Look at this. Here is one incident ray which is parallel to the principal axis. So after reflection will pass through focus. Then we have a ray which passes through the focus because it's not possible for us to draw through the center of curvature anymore. So we take the ray which passes through the focus. After reflection, it will become parallel to the principal axis. So these two rays will intersect at a point. So we have an image formed here. So we have the intersection of the real reflected rays. So such an image is called the real image. A real image will always be inverted with respect to the object. Inverted means it will come upside down to the object. When object is up, image will be down. Okay? So we have inverted with respect to the object. And a real image can be obtained on a screen. So if you keep a screen here, you can locate this image. Okay? Only a real image can be obtained on a screen. Please don't replace the word obtained with the word seen. You can see other images as well, but not obtaining them. Okay? So it has to be obtained. Then virtual image. The image formed when the reflected rays produced backwards appear to meet at a point is known as a virtual image. Look at this. Is formed when we have the rays, all right, here I'm showing you only one. So when the rays which appear to backwards appear to meet after we produce backwards, not actually the real rays. Real ray is here, but here we produce them backwards. When you get an image in such a case, we call it a virtual image. A virtual image will always be erect with respect to the object, which means if object is standing upright like here, then image will also be upright in the case of a virtual image. And a virtual image cannot be obtained on a screen, okay? You can see it, but you cannot obtain it on a screen. All right, so that is the big difference. And there are 3 points of differences between real and virtual images. And all the 3 points of differences, I have included them in the definition. So please learn the definition, and when you get to differentiate, you just write these 3 points in the form of a table. Now, steps. How to draw the ray diagrams, okay? These are not given in your textbook. And here I am guiding you how to draw only in the case of a concave mirror, because many ray diagrams you will have to draw in case of a concave mirror. But for the convex mirror, please go through the textbook. Step 1, draw any line on the paper, okay? Draw any line on the paper. Right. Step 2, on the line, that means on this line which you have drawn, for you don't have to take like what I'm showing you. You can draw it on the same line. But look what you have to do. Step 2, mark center of curvature C, focus F, and pole P with measurement, say 1.5 centimeter. This is my advice for all the children who do the ray diagrams. I ask them to take the measurement 1.5 centimeter, all right? Because more than that, I find it will be too long. Less than that, I find it will be too short. So, unless and until mentioned in the textbook or in the question, otherwise, you measure 1.5 centimeter difference, okay? Look, how do we mark? First, P will be on one extreme end. P should be on this extreme end, okay? All right? P. And then next to P comes the focus. So, from P to F, it should be 1.5 centimeter. So, this will be the focal length, okay? Remember, focal length is half of the radius of curvature, or radius of curvature is twice the focal length. So if this is 1.5, to go to C, again you measure 1.5, because these two distances are equal, okay? So we measure, mark them in such a way, P on the extreme corner on the right side, then F with a distance of 1.5 from P, then comes C 1.5 centimeter from F. Remember the sequence. You are not to keep C here, you are not to keep F here, nor F here, okay? These are their positions, P, F, and C with measurement. Okay, step 3. Draw the outline of the mirror through P. Now, why am I asking you to keep P on one extreme end? Because mirror will come here. Okay? And as far as possible, children, I would like you to practice drawing these mirrors by freehand. Please don't use a compass, don't use any instrument. Practice to draw by freehand, because in ICSE you are not allowed to do it with any instrument. You are to draw by freehand. So make a practice right now, okay? So draw the outline, and the moment you draw the outline, it means silvered surface should also be marked by these lines, okay? You should not make them too long, but at least they should cover the whole of this concave mirror. So reflection will take place on the inner surface. And the reflecting surface should turn towards F and C. Okay? Then step 4. Keep the object at a given position, which will be given in the question, say at the center of curvature. Now please listen carefully, children. Please don't mix up also. The position of the object will always be given, be it in your textbook, be it in the question paper, it will always be given. The position of the object is given, and then you are to draw the ray diagram. So according to the position of the object given in the question, accordingly you keep the object. Here I have just assumed, say at center of curvature. At center of curvature means we have to keep the object at C. Okay? So here is the object at C. Remember, in the rules we say the object should be on the left of the reflecting surface. So here is the left, and the object should be perpendicular to the principal axis. Okay, it is perpendicular and its foot touches the principal axis. So this is the way how you should draw the object. Okay, all right. Next, step 5. Take a ray from the tip of object parallel to the principal axis. It will reflect through F. Remember the convenient ray? It's not possible to take a ray through C because object is already at C. So what will be the options that we have? 1. A ray parallel to the principal axis. We know its direction when it is reflected. It will pass through focus. Okay, so we have a ray passing through focus. Then next, take a second ray from the same tip of object. The rays should be taken from the same point, from the tip. Okay, then now what will we take? The ray that comes from the tip of the object passing through F. Okay, through focus F. It will become parallel to the principal axis after reflection. So it will become parallel to the principal axis after reflection. Okay, we know. Remember, these rays are not drawn randomly. We take only the rays which we know where will they go after reflection. Right? A ray incident parallel to the principal axis, it will pass through focus after reflection, and a ray which passes through focus, all right, when it is incident, then it will become parallel to the principal axis. Now it's very important and it's interesting also. Remember, children, these two rays are just the opposite to each other. When incident ray is parallel to principal axis, reflected ray will pass through focus. When the incident ray is passing through focus, then reflected ray will become parallel to the principal axis. Okay, then we go to step 7. The point of intersection of the two reflected rays is the position of the image form. Okay, so this point now will be the point where the image is formed. So how do we get the image? Drop a perpendicular from the principal axis to the point of intersection of the reflected rays. What do? We drop a perpendicular from the principal axis till we come to the point of intersection of the two reflected rays. Then the image will be obtained. All right? And what will we do? After that, we will check whether it's a real image or not. How do we know it's real image? There are 2 points by which you will be able to know. 1, if it is inverted with respect to the object, it's a sure case that it is a real image. But the question can come. How do we know which one is the tip, which one is the foot? Okay, please listen carefully. Here is where you can make out. We take the rays from the tip, and these reflected rays are the reflected rays of the tip. Okay, so image which will be formed, remember the tip will be at this point of intersection. So the foot will be on the principal axis. Okay, so once you know that, then you will be able to make out whether it is an inverted image or not. Like in this case, it is an inverted image. Once you get an inverted image, then it is clear to you that this is a real image. All right. Then next, check the position. Where is it? Look, it comes at C itself. So position of the image is at center of curvature C. Then it is a real image, and then you compare the size. Okay. In this case, it will be equal to the size of the object. So that is what is mentioned, and then check whether it's a real or a virtual image, and then write the characteristics of the image. Okay, children, I'll be continuing with you in the next video. Thank you.